In lesson 7.4, we're learning about solving logarithmic equations and inequalities. So some important things to recall. One thing is how to go from log form to exponential form. And then something else that's important is remembering the rules from the last lesson. So we learned that b has to be positive, x has to be positive, and then we also learned that b is not allowed to equal 1. So b and x have to be positive, b cannot equal 1. Okay, so for number 1, we're going to take that logarithmic equation and change it to exponential form. So log base 6 of 216, 6 is the base, 3x is the exponent, and this equals the argument, which is 216. So quick review of vocab. The number down here is the base, and then the x is called the argument. Okay, so now it's similar to one of our recent lessons. We want to make it so that they have the same base. So if we break down 216, 216 is 6 to the third. And now we could cross these out, divide by 3, and x equals 1. Okay, so to check your answer, just make sure that the base and the argument follow the rules in the top right, and they do. So there's no variables in our base or argument, so we don't really have to check anything there. Okay, for number 2, we change it to exponential form. 4 to the 5th equals 4x minus 20. And now we have to multiply that out. So we have 4 squared is 16. 4 to the third is 64. 64 times 4 is 256. And then multiply by 4 one more time. And we get 1024. Add 20 to both sides. And divide by 4. So 1,000 divided by 4 is 250. 44 divided by 4 is 11. So then I add 250 and 11 together, and I get 261. Okay, when both sides already have a log, those problems are a lot easier. You could basically just cross these out and now solve the remaining equation. So we want to move everything to one side. So I subtracted the 2x to the left side, and I subtracted the 1. Now I'm going to factor. So everyone seems to have a different factoring method. Here's my x factor method. I have a -3 at the top and a -2 on the bottom. I'm looking for two numbers that multiply to -3 but add up to -2. So those would be -3 and +1. Divide both of those by 3. And this one simplifies to -1. All right, so I have x minus 1. And if I use the bottoms up method on the 1/3, I get 3x plus 1. Okay, using the zero product property, one of those has to equal 0. So either this equals 0 or that equals 0. So x could equal 1 or x could equal -1/3. Okay, then you have to check your answer. Remember the rule. The base and the argument have to be positive. So we don't have to worry about the bases because the bases don't have a variable. So let's look at these arguments up here. If we plug in 1, they both equal +3. So 1 works. if we plug in negative 1/3 here, well, the negative gets squared, so it'll be positive. If we plug in negative 1/3 there, well, negative 2/3 plus 1 is also positive. So both of these answers will work. All right, I don't think we checked the answer for number 2. Let's go back and check that really quickly. So if you plug in 261, well, there's no variable here, so you don't have to worry about that part. If you plug in 261, that will be a very big number. So yes, it will be positive. Okay, for number 4, we change it to exponential form. X squared equals 5x. Move everything to one side. X squared minus 5x equals 0. Then we factor, so we can take out an x. Using the zero product property, x could equal 0, or x minus 5 could equal 0. So our second solution is 5, and now we plug in, making sure that both of these are positive. If you plug in 0, well, 0 is not a positive number, so 0 doesn't work. If you plug in 5, we get the base is 5, and the argument is 25. Those are both positive, so 5 works. Okay, so now we're going to move on to inequalities. Now, we've done this example before. We know that the exponent that turns 3 into 9 is 2, and 2 is less than 4. However, if we turn this into exponential form, 3 to the 4th is 81, which is bigger than 9. So if you're going from log form to exponential form, one thing to remember is if you want to keep the inequality pointed in the same direction, you have to keep the argument on the same side. The argument is the 9 in this case. So if you keep that on the same side that it was on, then your inequality doesn't have to flip around like it did here. So keep the argument on the same side. Okay, when solving an inequality, the first thing you have to do is take the argument and set it greater than or equal to 0. So the first thing we do, we ignore everything else. And I think I misspoke. Not greater than or equal, just greater than 0. So take the argument, set it greater than 0. All right, solve. We divide by negative 3. And we get x is less than 0. We flip the inequality around because we divided by a negative. All right, and now we have to solve the original problem. So again, keep the argument on the same side if it's an inequality. So the argument is negative 3x. That stays on the left. And then the base goes to the other side with the exponent. All right, we have to divide by a negative again. So we have x is greater than negative 5/3. And now we have to satisfy both of these equations. So I'll make a number line. Negative 5/3 is the smaller value. 0 is the bigger value. All right, so one parent is saying stay below 0. The other parent is saying stay above negative 5/3. So where do they overlap? They only overlap here in the middle. So how do we write that solution? That would be negative 5/3 is less than x, which is less than 0. Okay, for number 6, again, first thing you do is check the arguments. So 8x plus 5 has to be greater than 0. Subtract 5. 8x has to be greater than negative 5, and divide by 8. X has to be greater than negative 5/8. All right, now we check the other argument. 6x minus 18 has to be greater than 0. Add 18. 6x is greater than 18, and x is greater than 3. All right, and now we have to solve the original problem. So it looks like they both have a log base 7, so we could kind of ignore those and take 8x plus 5. Set that greater than 6x minus 18. Okay, so if I subtract the 6x, that gives me 2x. If I subtract the 5 at the same time, that gives me negative 23. So x is greater than negative 23 over 2. Now we make our number line, and we have 3 things that we have to keep satisfied. So let's go in order. The smallest number out of the 3 was negative 23 over 2, then negative 5/8, and then positive 3. All right, so the first inequality said stay over here. The second one said stay over here. And then the last one, well, they're all greater than. All right, so where can we go and all 3 of them are happy? Only over here. So that's the only area where all 3 of those lines intersect. So final answer is x is greater than 3. Okay, more examples on the back. Don't forget to check the argument first for all inequality problems. So set the argument greater than 0 and solve for x. And now we solve the original problem. The original problem, you have to keep the argument where it is. The argument is what's next to the base. So 3x minus 3 stays where it is. The 9 moves to the other side. Okay, how do we do 9 to the 1.5 power? Well, first I recommend turning it into a fraction. So 1.5 is 3 over 2. And now if you recall from first semester, you can turn that into a radical by making the denominator the index. So the denominator would be 2. That would be our index. You don't have to write it, but you can. Okay, so now this is the square root of 9, which is 3 to the 3rd power. Okay, 2 more steps for this part. That would be 27. 3 times 3 times 3. Add the 3. Divide by 3. All right, so we want a number that is bigger than 1 and less than 10. I'll set up a number line to help you to visualize that. So our numbers are 1 and 10. All right, so the first inequality is saying stay over here. The second one is saying stay below 10. So where do those overlap? They only overlap here in the middle. So we have to write our solution to reflect staying in the middle of those. So that would be 1 is less than x is less than 10. Okay, so always remember, check the argument first. Argument has to be greater than 0. So x has to be bigger than 1. 2x also has to be greater than 0. So 0 divided by 2 is just 0. And now we check the original problem. The bases, or the log and the base are the same. So we could get rid of those. Subtract x on both sides. And so if negative 1 is greater than x, x is less than negative 1. Let's make a number line to see where those all intersect. The smallest number out of the 3 of them is negative 1. followed by 0, and then 1. All right, so the first inequality said stay over here. The second one said stay over here. And the third one said stay down here. So notice those don't all intersect ever. There's a portion where 2 of them intersect, but never do all 3 of them intersect. So this one has no solution. Okay, for number 9, we check the argument first. And now we change it to exponential form. The argument stays on its side. 16 goes to the other side with its exponent of 0.5. Change 0.5 to a fraction, and an exponent of 1/2 just means take the square root. So we take the square root of 16, and that's 4. All right, so where do we need to be? Make our number line 0 and 4. One says bigger than 0. The other inequality says greater than or equal to 4. So where did those overlap? Those overlap right here, and that includes the 4, because equaling 4 will satisfy that and that. So we are allowed to equal 4 as well. So final answer is x is greater than or equal to 4. Okay, 2 arguments to check. 7 minus x has to be greater than 0. Subtract 7 to the other side and divide by -1. X is less than positive 7. And now let's check the second argument. Okay, so set that greater than 0 and subtract 19. X has to be bigger than -19. And then the last thing we have to do is check the original inequality. 7 minus x has to be less than or equal to x plus 19. I'm gonna move all the x's to the left. So subtract x, we have 7 minus 2x is less than or equal to 19. Subtract the 7. Negative 2x is less than or equal to 12. And divide by -2, because we're dividing by a negative, the inequality flips around. 12 divided by -2 is -6. Okay, so for the number line, the smallest of the 3 numbers was -19, and then -6, and +7. Okay, so the first inequality was an open circle, and we wanted to stay over here. The second one was also an open circle. Stay over there for that one. And for the last one, it was a closed circle, and we wanted to stay greater than that. Okay, so where do all 3 of these intersect? It looks like only in the middle here do they all intersect. Okay, so notice we have a closed circle on -6. So I'll write -6 is less than or equal to x, which is less than, and we have an open circle on 7. So that is just less than. All right, next we have a word problem. So they give us one equation, and that equation has 2 variables. So they'll probably give us one variable and we solve for the other. So I see a variable n and a variable f. Then looking at part A, the question is, how many notes? And notes are n, so we're solving for n. All right, so if we're solving for n, they have to give us f. And so if we look back at the problem, they tell us the frequency is 440, so I'm going to plug that in for f. So 440 over 27.5. Okay, so using a calculator, 440 divided by 27.5 is 16. And now we have to figure out what is the exponent that turns 2 into 16. 2 to the fourth power is 16. So that log equals 4 because 2 to the fourth is 16. So we have n equals 1 plus 48. So our final answer is 49. And these are notes, 49 notes. Okay, one more. And it's pretty much the same thing, but with a different frequency. So 1 plus 12 log base 2 of 1,760 over 27.5. Okay, so that fraction is 64. So it's 1 plus 12 log base 2 of 64. Okay, so what exponent turns 2 into 64? 2 to the sixth power is 64. So this log equals 6. 1 plus 72 is 73. So our answer for this last part is 73 notes. Okay, that's it for this lesson.